I hope I can live up to all the way you've hyped my presentation and me. So as Jenna said, this is going to be a presentation on performance testing. And I was kind of moved to that because it's kind of an afterthought, and we're going to see that a little bit later. But if we were in the live setting right now, I'd be asking who has already done some performance testing. And my suspicion is that there would be very few of you. So let's just go and I'll give you an overview, and then let's just jump right in. So I'm going to talk about the concepts of performance testing, and that's more or less independent of which tool you are going to be using. Then I'm going to have, it's a section here, but it's really only a slide, listing some performance tools and their properties. And then I'm going to go in the second half of the presentation into one of the load testing tools, Gatling, in detail. It's an open source tool that you can just download and play with. And it's been used throughout, well, quite a bit throughout the project I'm using and also in a previous company. So let's just dive right in. When we're talking about performance testing, what are we actually talking about? And of course, the thing that first comes into mind is we want to see how our website operates if people are using it. So that would be for regular operation. So that's people come in and they see that, and we have a certain amount of traffic. And before we deploy, we want to see how any changes we have made has affected the performance over time. So that, of course, is the most obvious one. As you can tell from all that space, there's quite a few other ones. So let's look at what's there. So, okay, so the next one is a temporary traffic increase. So what does that mean? It's, I tell you a little anecdote. I once worked for a company that had a publication in the States. And it was a fairly small, kind of wonkish publication about the US government and what was going on there. And it was all going well until sometimes an article that they published was picked up by a big US newspaper, like the New York Times, the Washington Post. And then suddenly traffic skyrocketed. And it went so bad because our systems weren't performant enough and we didn't test for it, that we actually had to remove the payment gateway just to handle the traffic. So that would be a temporary traffic increase. Let's say you're being picked up by a news site, or in the US, if you have Black Friday and suddenly everybody goes shopping, or promo or something like that. So that would be a second scenario that we could think of. The third one is capacity limit. I'm going to show you a little bit later what that means, but it basically means to figure out what the performance is like at certain capacities, and then you can, or certain traffic, and then you can later on make a determination of saying, okay, what is actually our anticipation, and how does this work, and is this okay or not? Then long-running usage. I assume if you're a developer, you've sometimes noticed that due to some programming error, there's some threads that get lost, or threads are killed. So there's a test that basically runs long-term and sees how the performance changes over a longer term. And then closely related to this temporary traffic increase, or sorry, to the capacity limit, is the breakdown. So in this case, we're ramping up slowly, and we see at what point our system starts to throw a lot of errors and fails, and maybe in the end, we destroy a server. So that kind of hints that we're not doing this against a live environment, but against a testing environment that's specifically spun up on basically metal or on servers that are of similar capabilities. So let's look at all those, what this looks like. So these are charts of the number of users over time. So for a load test, you don't just start with a 1500 right away. You just kind of ramp the system up. And just like in real time, it's people don't all start at 7 a.m., but some come in at 7:01, at 7:03. So this will be a load test. The capacity test kind of goes up, keeps it there for a little bit to see how the system shakes out, increases to the next level, until we've said, okay, this is this is all that we want to test. And then the spike test that I alluded to on the previous slide is we have a certain level at which the system runs. And then suddenly we have a spike. So you could use this, for instance, to test how quickly your auto-scaling features work, if that's fast enough, or those kind of things. So basically a temporary traffic increase. Then here's the soak test. It's probably nothing surprising. It's kind of like the load test, except that we keep it going for a very long time. And then similar to the capacity test, we have the stress test. And so this really goes up and up, and it's the same paradigm as the capacity test. We ramp it up, we keep it there, but we'll go further than the capacity test. So we've looked at how our traffic shakes out, but there's two different websites that until I started doing this load testing, I kind of was aware of, but it wasn't really front of mind. So Gatling has this concept of open versus closed testing. So closed testing, as it says here, we have a defined user count. So where a user finishes a task before a user can start another one. So an example would be a web application, for instance, that's used internal to a system. So a company might not purchase software that's being used for their businesses, but they might actually write software. And of course, they have a set number of employees. Yes, they numbers go up and down, but it's nothing dramatic. So you basically have a closed system with a set number of users. And if you were to plot this over time, you would get something like this. Users over time. Here's again the ramp. I'm saying, just so I don't have to draw 10,000 rows here. Let's say 8 concurrent users, and we're adding 2 per time unit. So here you see it goes up. And then as soon as one task is done, it immediately starts the next and the next and the next. And it just keeps going until you basically you say, I want to run for 10 minutes. And then after 10 minutes, the whole thing is done. So that's the closed tests. And of course, if there's a closed test, there also is an open test. And that's probably something that we all think of as consumers. We think of the Amazons, we think of the Airbnbs, of the ride-hailing websites. So they're all open. So that means there's no set number of users. So you have a big sales event, like in the United States, the Black Friday, and you get flooded with a certain number of users per second. And so for that, this will look very differently. So it'll look like this. So here we have, just like before, we ramp up, that's all no problem. But then as we're adding 2 more users, this per time unit, this one here has finished, so we can reuse this, but now all the other ones are still working, so we have to add another one. So you can see from the shape of these 2 graphs that they're very different paradigms. And if you set your tests up to do a closed test, but you really have an open system, you're essentially getting data that doesn't really tell you all that much. So that's the first kind of decision you need to make is, how am I going to test my system? Then the other thing is, how do we know whether a system is actually good enough? And that's where this concept of fitness functions comes in. And I assume many of you, if not most of you, already know what's meant by this, but let's just look at this anyway. So we have, we build our code, then we deploy, and then of course we run the unit tests to make sure all the code runs. Then we do a build and a deploy, and then we do integration tests. So we check the backend with the front end, for instance, and then we do end-to-end tests to test everything. And what's common among all these testing things is that they're very determinant. A unit test passes or fails. And then you can say, okay, one unit test fails. That means our system, under certain circumstances, fails, and we know that, so we're not going to deploy. The concept of fitness functions is a little different when you see what it is. So code quality, it's in my book, it's a very important thing that code is formatted consistently, so that when new developers don't have to learn 5 million different coding styles. So that's something where you can't say yes or no. You have to set certain parameters around this. What does my code quality look like? And those kind of things. Then compliance to standards. This is important in Europe with data privacy, resiliency testing, observability. And then over here on the top right, you see also there's performance testing. So We'll look a little bit into what how we can codify these fitness functions. But so we do all of our unit tests, integration tests that are very determinative. And then we can here use our fitness functions to test some things that we have to define that are a little bit more vague, so to speak. And only when all of this passes, then we're going to promote it to production and bring it so people can use it. So the question then is, what does failure really mean? I already said that unit test is pretty clear cut. But if we have these fitness functions, what does failure mean? So here I borrowed from Martin Fowler here this testing pyramid. We do unit testing, service testing, and UI testing. And with all respect to Mr. Fowler, I decided to change this a little bit for my purposes. So basically, in a system, we can do unit tests, which means the functions. But in performing tests, that's really not possible. We can test against a closed system. So it means the lowest we can go is basically we can test, for instance, APIs. Be they REST APIs or be they APIs for queuing systems or Kafka or something like this. Or we can test actually through the UI. So these are the two testing paradigms which I'm going to be roughly talking about. I'm mostly talking about the APIs. And so if we're looking at this a little bit more, we say, as I said before, a request fails, or the received data is invalid, or the response time is inadequate. So that's all tests that are really just like unit tests. We can say yes or no. But then the question becomes, when do we fail? And so there we can say, okay, we have done 10,000 requests, and out of those 10,000 requests, we want to have a maximum of 2% failing or something. And that's been codified in the fitness functions. So let's look at this next. So when is good enough? And there is a thing, specific and quantifiable. It doesn't help me anything when somebody says, yeah, the system should be so that users are happy. That's not specific, that's not quantifiable. I can't really write any code against that. Unambiguous. So we should just not say, oh yeah, for instance, on the user management system, the performance should be like this. So then we have, for a shopping cart, for instance, we have the order history. Is that now part of the user management, or is that part of the order management? So we need to really be clear about what it is that we're going to be testing. And then, of course, with fitness functions, we should only test one criterion. So we shouldn't say, oh yeah, we want A to happen and B. Then how do you weigh those two? That's kind of a point where you go and say, let's write two fitness functions and then codify those separately. And for these performance tests in particular, as I mentioned before, we are not running tests on the server. We're running a system on the outside that does requests against the server. So any kind of fitness function that we write needs to be verifiable from the outside. So mostly performance times or how many failures we can have for requests. So here's an example. So HTTP requests to fetch a list of non-customized products. So you see that's already very specific. Should respond within 600 milliseconds under standard load conditions with 300 concurrent users. So if you write a sentence like this and you give it to your programmer, the programmer gets a pretty good idea of what the test actually should do. If you leave out some of those things, fetch a list of products, then the question is that really specific enough? Is it unambiguous? Could this be non-customized? They might have different performance issues, different payloads, different processing on the server. So be as concise and be as specific as you can. And of course, this is just an example. There will be many more. So when to start? So here's kind of like an imaginary timeline for, let's say, a new project. So the project kicks off, everything's great. We go and code and we have our first API complete and we're popping a bottle of champagne and say, awesome, let's keep going. And then the second API is complete. And then eventually if we're doing domain-driven design, we have the first domain complete, and the second domain, and then we're getting close to rollouts. We're doing acceptance testing, and then we're doing the rollout. And I'm not sure about you, but in my experience, when we start performance testing is right about here. Way after rollout, when there is some problems, And our manager comes in and says, why is suddenly the server cost so high? Or why is every morning at 9 a.m. is there a problem with performance that, half the connections break down? So probably unsurprising to you, my not request, but I would tell you to start before the first API is complete, because as you're developing, you lose information, right? If you start way back, you have no idea what the performance was early on. And only if you have the entire history can you make a determination of which specific code changes had this effect on your performance. And then you can say, okay, this happened on this day. We had these 5 commits. So one of these must have done something. So at least you now have a fighting chance to figure out what might have caused it. Much better than when you do it, a year after the rollout. So that's kind of a rough overview of the concepts, and these are pretty much applicable to any system. And even though I talk about Gatling, there of course are several others. So here's just a selection. This is by no means a recommendation. So I'm talking about Gatling today. It's programmed in Scala, and you see down here the GUI, the GUI. You can also go and build your tests on the GUI. I'm going to go and talk about the coding. You're going to write this in Scala. It's free to use, and the most popular and most used protocols are supported. So we can do HTTP or secure HTTP. We can do WebSockets or message queues. And there are a few more other ones through second-party projects. Then here is the grande dame of the performance testing. That's JMeter. And that's a really set system which has a lot of protocols that are supported. It's free to use. It's in Java. The bad thing in my book is that, yes, you can code, but mostly you're using the GUI to build your tests. And again, it works great. I've used it. Being a programmer, I really like the way of coding, though. Then case 6 is an interesting little, to me, fairly newcomer that I would want to play with. It's actually written in Go, but you write your tests in JavaScript. Again, it's free to use. All the major protocols are supported. And here you don't have a GUI. All you can do is write code. And then out of the plethora of commercial systems, I just picked the Load Ninjas here. So they're not free to use. Again, they have probably an even bigger selection from protocol because they are commercial and they have big commercial customers. And this will be all GUI and no coding. So the choice is yours. If you like to get your fingers dirty and code a little bit, there's options. Or if you just say, I'm not really into coding, I'm just I'm a BA or I'm a QA person and I'm not comfortable in code, there are also options for you. So with this, let's look at Gatling and what it is. So let's just give you a brief outline. If we're looking at a test, let's say we're doing a website, we're having HTTP, and there's various different steps that a test logically can do. So the first thing we can do is a protocol configuration. And for instance, you could imagine that a website has a public API and a private API. They have different protocols potentially. You have maybe a system that you want to test as a whole that even maybe uses message queues. So we need to define all the protocols for all the requests that is in common. I'm going to go into that in just a second. Then, of course, the most important thing is we need to do the requests to the system, which actually determines the performance. And then the traffic patterns. We saw before the little charts with a spike test or a regular test. So how do we define those? And then we say, okay, we need to figure out if a request has succeeded or not. We'll do that with checks. And as I said before, all the checks bubble up to something that says what percentage of my checks have failed. And that's done with assertions here in Gatling. So let's start our journey. If you start reading about Gatling, as I said, it's written in Scala. You see an example like this, where we're having all kinds of different things. And this is basically like a script. So using the same colors here on top, we have the protocol definitions, then the XX are our requests. Then there are the checks with the light blue. We have our assertions there. And then our scenarios, which is in this little neon green. But if you're doing many different tests, let's say you want to say, habitually, I want to just do my usual load test to see if anything has changed. And once a week, I want to do my spike test to see how the system works, or a long-running test. And we actually might want to reuse some of those building blocks. So one thing that I've gone to is building my toolbox. So I'm defining my protocols in separate entities, classes, traits in Scala. Then we have different domains with the different requests here shown in orange. And then the traffic patterns here in red. And then you can, keep going with this. But what this allows you to do is saying, okay, we've got our toolbox now, and we can use all these tools to build our load tests. And we can use the same toolbox to build our spike tests. So if something changes with the ratio in the requests or anything like that, you can do that in the load and the spike tests, but your toolbox is basically giving you the building blocks for your tests. And this has made my life a little easier. So this is just a little wing. So let's get into the details. How do we define a protocol? So here we're doing HTTP. So the first thing we want to do probably is, if we're having continuous deployment, continuous integration, we want to have this run on multiple different environments. So we need to specify URLs from the outside. So this is done here with the Scala util properties. We're grabbing the offer URL there, for instance, in the first line. And if it doesn't exist, we're just using a default, which is handy to use locally. Then for the requests, they're always going to go against the same domain. So we're going to define a base URL. This warm-up is a little Gatling/Java special. There are some requests being made before the test starts. And of course, they should not affect the system. So this is how you specify that. And then the rest is essentially common headers for your requests. So here we're saying, okay, every request should accept JSON. Here's the language. And then we do things that, for the requests, because the processing of requests also takes time. You can skip them potentially, but, auth JWT here you might use if you're using an authentication system for this. So this is how you would define the protocol. And again, you can use this for HTTPS, for HTTP, for queues into your toolbox, and you can build your tests fairly quickly without really much ado. So the next thing we need to do, obviously, is do the requests against the system. And here is a Scala special. It's called traits. And a trait is essentially not an object. It's an entity where you can use multiple inheritance, and you can't instantiate those. So they're perfect for the requests because you can't really use them individually. So I found this really helpful when I needed to mix and match requests from different domains, for instance. So let's look at what this looks like. So this is again Scala. Those of you who know the language, this might look familiar to, but we're defining a method here where we're passing a UUID, for instance. Then we're saying, okay, do an HTTP request, and we give it a name, and that will show up in your reports. So you can see how long or what the performance statistics for those requests were. And then we're just saying here, go to this URL and use the past UUID. So you notice that none of the things that we just defined before, like the headers, is necessary here. So this is really nice and clean. So you can use the same request with HTTP, HTTPS, maybe some other headers. And you can do the same thing again here for the load pricing deal. You can also do, of course, patch requests and all kinds of other requests. So here we're passing the body as a string. You can also pass it as a map. So you can build your map in your code with any kind of data that you want. And then this is how you would go and say, here's my map, and this form param map method on the HTTP is creating the request from that with that data. So there's a lot of options. This is just a high-level overview. There's some more things for your request, but I think this gets you started and fairly far. So we talked before a little bit about the user behavior simulation. So if we're thinking about, yeah, okay, we're testing requests, we're testing the performance, but exactly what do we do? So here's one approach, and I've actually have seen that, where we're saying we have all these APIs, all these endpoints saying get product list, then we get a product, then we get user info, and the different colors are different domains. So the first one is the shopping cart, the orange one is the user information, and we'll just go through and we make a request to each one of those APIs. And what this would look like over time is we're basically doing this, and you can do that and it gives you some information, but to me, it's kind of a little bit of a glorified integration test, where from the outside, you're hitting each endpoint once, and yes, you get a little bit of performance information out of it, but it doesn't really tell you how your system really behaves if people are actually using it, or if more than one user is using it. So the other way to do this is you could do this. So you see now you have all the blue ones as one domain. And this kind of simulates a little bit how a user would use it. It gets a product list, looks at a product, and then maybe the page has a list of similar to this product or people have also looked at. So he goes and clicks, or she goes and clicks for other products, and then one catches the eye and says, okay, let's look at the specs. And say, yeah, this looks good, I'm going to add it to my cart. So what this kind of user behavior would give us is something like this. We still have the two separate domains here by the hashed bars and the clear bars, but we can change the number of requests per API endpoint. So that's already pretty good. But if you think about a real system, just think big, think about Amazon. There are some people at any point in time who do their shopping. Some people sign up for new accounts. Some people complain about something. Some other people, check out. Some people shop. There's all kinds of things. So in our tests, we actually do want to do this, where we're having multiple different scenarios run at the same time. And that gives us a little bit like this, where at the same time we have requests to multiple different points, but we're running both of those simulations in parallel, thereby more closely simulating how the system actually is being used, and not just doing, first we're testing the users, then we're testing the shopping cart. So to get all this information, of course, logs is the deal. So here is an example, and you notice here the requests have UUIDs in them. And here you can even see that there is multiple requests with the same UUID. So this already gives you a pretty good idea of how your system is actually being used. And so this is what you would look for. But of course, it's tedious to go through all of this by hand and make little check marks and count by hand. So that log file, you would go into, for instance, the shell script. And this is actually the one that I have used as a first approximation that goes through this, changes the UUIDs into basically the string UUID, and then counts them. And so this is what you would end up with here. Requests per day, and then you can do some math per hour. Here's the APIs. And then you can come up here in the fourth column from the left. How many requests per endpoint do we have? And this is really what you're after if you want to do your tests. And then here down afterwards, you can say, for each endpoint, how many HTTP verbs do I have? A post, a get, a patch. And based on that, you have a pretty good idea of how your system is being used. So over on the right is, again, something that I had used here before. So you see there's roughly 4 little sections. So the first ones are visually separated here, the first 3, and then the second 3. And then here's a whole bunch that has offer data. And then here's some health statistics. So based on this, we can get the ratios. And then we can say, okay, so we have this many requests of this, and then we can kind of start to build our story a little bit. So we have, our negotiation, and somebody does a demo, looks at some static information, goes back to the demo, maybe to another demo, and so forth. And here, this is probably the most intuitive to see that somebody does something, they post a request, let's say for pricing. And then they go, maybe it's a big thing, like they're buying, I don't know, an RV, and they want to see about options for financing. Then they have something to trade in. And then they're going to say, okay, I've done this. It goes back to get the pricing information, adds the traded information, and then we update our pricing. So this is kind of like a story that actually might happen just based on these ratios. And then, of course, you can keep going for this and for this. So now we have essentially 4 different tracks that all happen at the same time. So the last ones are system requests that basically make sure our system is still up. It pays to include those as well, because even though they're not big contributors to performance, they still might influence every once in a while. So these are the simulated user behaviors, and Scala calls those scenarios. So you see that scenarios are made up of sequences of requests. And that's what we're going to be looking at, is what this looks like in code. So here we have, again, we define a method that doesn't take any parameters. We define our scenario called process pricing deal. And then we group all of these, and this will become more clear later when I'm going to show you some examples of the reports. So this is essentially that down the line, you can actually know what those numbers mean that you're getting. And then we're starting here by executing the request for load pricing deal and pass it a UUID. Sorry, I forgot about this. So once the request is done, of course, computers are really fast, and if you don't tell them to wait, they just keep going. So to simulate human behavior, we tell Gatling, okay, after you've done this request and the response has come back, wait for between 3 and 6 seconds. And only then do you go and do the next request, which now takes 2 parameters. And the UUID I've shortened here because it would have been too long. And then we pause for another second, we do the third. So with this, you have your scenarios that you have found through the logs, and you can basically map those to this code pretty straightforwardly. And so this is good. This looks good, right? But there's a little problem with that. And let's look at what's actually happening if we were to use something like this. So here's a little sequence diagram. As a user, we go to the UI and say, please show me information for this item. And then the UI, maybe a single page application, goes to the server and says, please give me the data. And the server says, okay, great. I'm going to go to the database and run a query. So database does a select, the data comes back, and it goes all through the layers back to the user, and the user is happy. And this is so far so good, but you can see on the far right-hand side, there's some extra space because that's not all that's happening. What's actually happening is database improvements or performance improvements, or optimizations, I should say, okay, for this query, I'm going to store it in the cache. And of course, they don't do this just because. They do this in anticipation that the same query gets run again. And if it does, it says, oh, cool, I got it from the cache. So I don't need to do the select. And the select is really the most expensive of these operations. So if you are constantly using, like I did in the previous case, the same ID or the same UUID every single time, you're likely to get some data that does not fully reflect the performance of your system. So for that, Gatling provides feeders. And so these are, again, little Scala inside here. Objects are essentially singleton objects that you don't need to instantiate. So they're really nice for using it for these feeders. So let's look at one here. So this is, again, a function that is basically saying, from the Gatling iterator, continuously create me a map where the key is UUID, and we'll create a random UUID that we're going to create, that we're going to turn into a string. So you're going to see that all these methods I'm going to show you has this UUID or has this map in it. And that's because in the tests, if we want to use a value, we have to have some kind of handle, and that is solved with maps in these feeders. Another way to do this would be to use a CSV. So here we're saying load this CSV, and the eager means load all of it at once. Gatling also gives you an option to load it chunk-wise, and once the chunk is done, it goes to the next one. And from this loaded chunk, pick one row at random. And this is what I have done so far, because what this also allows you to do, in a step before you actually run your performance test, you can use that same CSV to prime the testing database. Because if you were to just generate UUIDs, that's all fine and good, but your database is not going to find anything because they're just random UUIDs. So with this CSV, you can actually go and prime your database with the data that you want in there. And then you can use that same CSV for the testing. So you can actually make sure that you're actually exercising the database and get some real data back. And you can do those little stories, those scenarios that I've shown you in the previous slide, and basically have it reflect reality. Then here is another way. We can also basically pass back a map, which then gets turned into a corresponding JSON object. And then we can get really fancy, where we can nest these hash maps, and we can create a JSON from it. And then here, just like in the first two, we just create a map with a key pricing information that has the serialized object, JSON object, as a value. And so in your code, you would basically get a variable that says pricing information that you can just stick in wherever you need it. So this is a very, I think, intuitive way to do your data. So let's see how this is being used. So the first three rows we've already seen here. We define a function. We provide a scenario with a label, and then here's the feed. And again, you pass a function reference here. And in our previous thing with the CSV, the first row is the labels. So in this case, if you see in the next line, there's a column that's called UUID. And we pass that ID that we've gotten from the feeder into that function there that actually has the code that executes the request. So we're executing a request with the UUID. And then we wait for 3 to 6 seconds, and we have another feeder that has data for an update, and so forth. And here we see in the next exec, we're updating the pricing information with that key in the map that contains the pricing update and the UUID that we have gotten before. So again, this allows you to essentially automate what users would do with your scenarios and have the data be different to not run into this database caching optimization. So I hope you haven't fallen asleep yet. I can't see the audience, unfortunately, online. But this is the thing the list of the building blocks for a Gatling test. And so we've talked about the protocol configuration. We've talked about the requests. Traffic patterns, we have talked a little bit, a part of it, there's still more. We've talked about how we can build our scenarios out of the requests, which is part of a traffic pattern. We have not talked about the checks and assertions yet, so we're roughly at about the halfway point. So if we wanted to simulate a user behavior before we set just regular performance or a spike test, and so here we have basically this regular test, and this would be codified like this. So basically a function that returns a sequence, and here we ramp our users from 0 to the user count. And then we say constant users per second. So this is the users per second that get added. And that's a constant. You can also then do these things. So this would be a spike test. And as you can imagine, this would be just basically the same principle where we're having a method that returns a sequence, just that we have more steps. So here we go and say at once, we start off with 2 users, then we ramp it to whatever we have specified the user count. Keep that here for 15 seconds, ramp it up in 60 seconds to the next one, and so forth. So again, this is a very, very speaking way of coding this thing. And before I mentioned open versus closed, and this is really showing the only slide showing what the difference is. So this is again running this or defining this this function. And here we saw before this at once users and users per second, and that's the hallmark of an open test. And we saw with closed tests that we basically limit our number of total users. And the principle is the exact same thing. We just use different methods. So here we say constant concurrent users, and then ramp the concurrent users. So this is the same schema, this is the same approach, only with different methods names. So not that big, but I thought this might be interesting for people to see. So if we're looking at this now, we have our run scenario closed with, and this allows us now to basically reuse the same scenario for multiple different request scenarios as we've seen before. So here is something, we're using the method that uses a constant for trade load users and runs it for 2 minutes. And then we can use that same function to run another progression and yet another progression. And then of course we can, in our code base with the scenarios, we can define other scenarios. So here's one run scenario continuously with 1 users. So this would be something where you're basically having health checks and you don't really ramp them. You just have 1 user that continuously pings until the simulation is done. So this was that. So now let's get into a little bit into checks. So if we're thinking again of how users use systems, we have list pages. And the user goes and says, I want to see more about this detail. So what happens is we're making a request to the server, and then we get the data to show the next screen. So the tasks are, we need to load a list of entries, and then we need to extract the information from the past data. So in this case, the 1423, to then make the request to get the next page. And for that, Gatling provides something called checks. So here's how they would be used. A lot of this should be looking familiar already. This is how we do it with the API. So here we execute our request. And once that request is back, we're putting in a check on this request. And what this check does actually here is not checking any values, but it's looking into the data that's being passed back from this request and says in this JSON, so this JMS is a JSON parser, there is an object called dealer list that has an array of dealer. Pick the first one and give me back the ID. And once you have that, save that as a variable in my session as dealer ID. And then it says, wait a second. And once that second is done, it executes the next one. And here you see the dealer ID that we have just extracted from the previous request now gets reused. So this way we can also make sure that we're not hitting IDs in our database that don't exist, and we can have some realistic testing. So the first one is how we would do it with an API. If we were to do front-end tests, so in other words, we're using the web, we're simulating a web front-end, you would use a feeder here to contain a bunch of dealer names. So we're making the request. We get a feeder with the dealer names, and we're saying, okay, from the HTML that gets returned, use just the CSS selector of a link that contains the dealer name, and pick off the data ID attribute and save this as dealer ID. And then it just keeps going just like the API. So these are 2 different paradigms, and you already see that they're really, really close to each other. So it's not really a big jump to go from one to the next. So we can extract data, but we can also, of course, the name check insinuates that we can validate things. So let's say here's a time list. So we get a list of information, then we load the detail entry from a list. Then we're sending an analytics ping. After that, we do load specification loading, and then we view product view reviews. And of course, that's all well and good, but we might want to know, is the data that we expect actually there? Or is the status expected? Do we get a 200 or will we get a 404? Did the request actually work? Did we get a 500? are the required headers set? So there's all these questions that allow you to permit whether that request actually succeeded. And so that's what the checks do. And of course, you would have them after each, or you could have them after each and every request. So here's how you would put this into the code. So here's again, we have a group where we do a feeder that it creates or provides a UUID. We're making our pricing deal request to the backend, saying use the UUID that it was just passed by the feeder. And once you're done, check using this. And so if you're not familiar with Scala, this is called the spread operator. And essentially what it does is it takes a sequence and applies each one of those in turn. So here we would check, does the status come back as 200? The data, is it the expected value? And then we get an array with entities. Is that the value that we expect? So each of these checks now allows you to permit whether your system actually behaves and provides the data that you expect. Based on that, as we talked before, you can do your assertions and make sure that you actually know that your suite passed. So here's again that little part of this testing triangle. We do the requests, they fail. And the test run fails if too many individual requests fails. And that's where, again, the fitness functions come in that we write down in the beginning, where we're saying we can't accept more than 1.5% missing requests. So let's look at this, what the difference is. A failing test run. So we have our checks. We say the first request should come back as a 200, and a certain property should exist, maybe have a certain number. For the second request, it's a creation, so that should come back as a 201 is created. The count in the response should be as requested or as expected. And also here for the third request, all the expected values should be there. So what is common among all of these is that the criteria are on a per call basis, and they mark a call as failed, but not the entire test run. For that, we would use the assertions. So assertions would be then request 2 has less than 5% failure, or all requests respond with 500 milliseconds, but requests 2 and 3 respond less than that with 200 to 400 milliseconds. And again, these are the incarnations of your fitness functions you define in the beginning. And of course, for each fitness function, you would write an assertion. And then in the end, your system can make a determination on these assertions, whether all assertions pass. And if they do, then great, it gets promoted and sent to production. Otherwise, you can fail your build and you can say, no, you need to do better than this. So again, this is for overall pass fail, and it marks the test run as failed or successful. So let's look at what the code actually looks like here. So Gatling uses the setup. We have our scenarios. So we have a trade-in negotiation, which is our scenario, which is the sequence of requests that we're going to be doing. Then we inject a certain traffic pattern, let's say just for a load test or for a spike test. And for these requests, we're going to use the HTTP API config. So, this is 1, and I showed you before we had 4. So now you would do this basically 4 times. You use different scenarios, and you see the last 2 use different protocols too. So ones are external, 2 are internal. And so this is running the test. And of course, the checks all check. They're part of this scenario here. And what comes out of those checks gets aggregated by Gatling. And then we come the assertions. So we say that the trade-in negotiation for this request should have less than 2% failure, and all responses should be happening in fewer or in less than 31 seconds, which of course is very, very large right now. But again, you set that to whatever your fitness functions do. I use this value for local testing and for developing my performance tests. So this kind of tells the whole story, and I think we're getting close to the end of time. So I'm just going to go and show you what the reports look like. Oh yeah, I forgot. Your next duration, you can also have little cherries on the top, where you can say, okay, if I have something that keeps continuing, I want to at most run this many minutes or seconds. So we've looked at protocols. We've seen how to do requests. We've done the traffic patterns, load test, spike test, all those kind of things. The two uses for checks is to extract data and to basically check whether a request was successful. And then the assertions, which aggregate all the information from the checks and then tell us whether the test run actually has succeeded or not. So here's some graphics, and Gatling gets you those out of the box. So here you see how many requests there were for each kind of bucket of request times. And again, this was run locally, so most of them take 1.2 seconds or more. Over here, you see the blue ones are the 4 different scenarios that were run. So you can see the number of different requests in each one of them. So that shows you can tailor your system pretty fine for how your users are using the system. So here is the assertions. So you see here that some failed, and it tells you exactly which ones succeeded. And then here you can see the statistics overall for these scenarios. So you saw before that we have a scenario called update pricing. Now in each one of these, there's different sub-scenarios. So here we have the total number of executions, how many were okay, how many were not okay, the percentage and the response times with percentiles, max, mean. So you got a pretty good idea of how your system works. Down here, it even reports to you which checks have failed and what percentage and how often. So you can go and figure out if there may be something that you can improve with your coding or bigger server or more services. And it also gives you here the number of active users over time. So you see that this is just a regular performance test ramping up to a constant value. And you can see here the blue, green, red, yellow, and the orange. So these are the 4 scenarios and the overall users. You can see the response time distribution. You can see how many requests were made and for all users, and you can see responses. So you see here, there's some red. So there were some failing. So you see here, initially there's very little red, and then here it starts popping up, and here it becomes a little bit more prominent. So this is all useful information to see how a system reacts over time. So with that, I'm ending up with my last slides, which is just kind of like an overview of the things we just talked about. And I'm not sure about you, but I used to like to play with Legos. So I'm just using that to to basically convey how Gatling builds. So we have protocols. And again, we can use HTTP, HTTPS. We can have messaging protocols. So we could essentially simulate a system that takes HTTP requests from the outside, and maybe there's some requests from within your microservice architecture that uses messaging services like RabbitMQ or Kafka. And based on the protocol, of course, we will make requests. So these are, I've shown you HTTP requests for posts, put, how you can create data for them that sends them. And this data, of course, comes from the feeders. So you can use CSVs, which I've used to pretty good effect, because I can pre-prime the database and then make sure that the database actually returns data and not just fire off some random IDs that really never lead to anything. After the feeders, we want to do the checks. So the checks is passing data from request to request, or to make sure that certain parameters that we've determined for each request actually are what we expect. And then it's held together by traffic patterns. So again, traffic patterns is a regular load test or a capacity test, or those kind of things. So based on this, you have your scenario 1. So this would be maybe people browsing your shopping website. And then you can do the same thing for people creating or managing their accounts, and for all kinds of other things your website might actually be doing. So you're running all of these in parallel, and all of this kind of bubbles up and goes into the assertions. So the assertions are overall saying, what does my system need to do in order for it to be successful. And then the final tip is, or the tip of the iceberg here is the miscellaneous. So for instance, this little thing that I showed in the end, almost forgot in the end, about limiting the run to a max number. And this actually comes in handy when you have things where you say every 10 seconds, do this request and run it forever. That's how you would use it to essentially go and do, make your test finite and not have it run forever. So that's my last slide. And so I assume there are some questions. So if you have questions, please fire away.
Wow, just want to say thank you so much, Torsten. That was so cool, so much detailed information about performance tests. So thank you. And we do already have some questions coming in. The first one is from Alex. So, and the question is, when using a messaging system, can you do checks assertion against another endpoint? For example, can you send a message to queue and another service should pick it up and write an entry in a database?
I'm not sure I follow the scenario that this person is talking about. Maybe.
Yeah, I can explain it if you want.
Yes, please.
Yeah, so let's say I send against a queue, then the load testing itself doesn't do anything other than firing against my message endpoint, my Kafka stuff, which is pretty fast in receiving messages. But something behind this queue sits there and wants to pick up these messages, does some calculation, and maybe produces an entry in a database. And what I now want to know is, how long does it take for each of my messages to be processed by the system that hangs at the end of the queue and actually processing the message and writing something in the database. So in my assertion or in my check, I want to say, send a message, wait, let's say a second or so, then check the database. If my entry is there, if not, I say a second is too long, I fail.
Right. So yes, that's actually a very good question. And I have not really actively worked with a lot of messaging systems to that level. My hunch is, since those messaging systems tend to be asynchronous, so I know that we're using it to, or a message comes in and it gets processed, but they don't really respond.
Yeah.
And what this system does is, that was a part of that one testing tray or testing pyramid, where I said we can't really do the equivalent of unit tests. And what you're describing is essentially a unit test. All we can do is test from the outside. We can fire something against it. And so my current understanding, and I'd love to hear if you have done some research and seen something else, but in my current understanding is that we could test and see how many requests we can receive per second. But since the processing is behind the queue and we don't really get an answer from that, the request is basically, we're making the request, and then let's say Rabbit or Kafka goes and puts it into the queue and says, yep, I'm done. That's your request time.
Yeah, exactly. That's my problem. That's too short.
Yep, exactly. It's pretty damn efficient. That's an interesting problem that I have to admit I have not really thought about, because it hasn't presented itself to me. But now I will.
Do you know, in a check, can I do like a REST call to a system to ask it, hey, for this message ID, have you seen this already? I mean, this would be enough, basically, if I could ask the system that listens to the queue.
That might be one potential thing, but the problem is, if you do the check, you're going to affect your scenarios, right? So you would write that that check is essentially it's a sequence, and you, as I showed you, can go and write a function that returns that sequence, and in that function, of course, you can do an API request to see and wait. But if you do that, then all the pauses you write in your little scenario, they're essentially meaningless. right? Because if you do a polling implementation in your method or in your function, then your check will take 10 seconds, whereas your pause says wait 2 seconds.
Yeah, but I'm fine with that, because I mean, I still could say how long it should take, right? I get a response, probably how long it took overall, and then I could react on it.
Yeah, you could. I mean, it depends. If you just do a one request per scenario,
yeah,
then that's definitely doable. If you do it like I showed you, you're doing a sequence, like like a shopping progression.
Yeah.
Where he goes and looks at a list, then looks at one product, another product, a third product.
Yeah, with a queue, that's not your scenario. With a queue, you typically fire one event, and then that's all you do.
True.
So I think in my case it could work. Thanks. I will try this out tomorrow.
Yeah, I mean, if you do this, I can't see what you're seeing right now, because I don't know, for some reason I have just one window. But I can show the email again, and if you find it out, I'd be really curious to find out.
Yeah, sure. I will definitely get back to you. Thanks.
Yeah.
Oh, that's so cool. Thanks for your question, Alex. I noticed you did write a bit more in the chat. Did everything that you wanted to get answered, was that all taken care of, or do you still have that other part about session attributes?
Yeah, there's a second question, but I don't want to take all the time. So if somebody else has a question, maybe.
I mean, there is there's another question afterwards, so we don't have a ton of questions. So I would be fine if Torsten, if you're fine I can read out or you can ask the question, Alex.
Yeah. Thank you so much. You showed the feeders with the CSV, and you put the parameters into the request. And I was wondering, can you extend the standard Gatling reports in a way that you can see the distribution of your parameters? For example, in your sample deals to CSV, you take always a random entry from the CSV file. And let's say at some point you will hit the same entry more than once, depending on how big your CSV is and the time you're running your test. And now I want to see, for example, did I get the same UUID twice, or how often did I get this?
You're asking questions. That's questions I hadn't really thought about. Thinking on my feed right now, the first question I have is, what would be the payoff if you did that?
Yeah, for example, I have a scenario where I have something like a shop with different partners, like affiliates. Mm-hmm. And I know that like 60% are coming from affiliate A, then 30% from B, and the rest from C. Mm-hmm. And now I'm writing a smart Scala code that tries to represent this distribution. But I would like to see a report afterwards in Gatling if that distribution was met. So if my test data really was 60% of partner A, for example. And the way I'm doing it at the moment is I'm constructing my test data in a way that 60% of my test data is partner A. And then when I hit random from pure statistics, I should get the distribution. But I would be really happy if I could see a distribution metrics in the Gatling report, like this is how many requests I fired with affiliate partner A, and this how many requests with B. That's my scenario, actually.
Yeah, okay. So let me try to give an answer. So the thing is, with these graphical reports, they're pretty baked in. They're HTML reports, so there is a way potentially that you could modify it. I think that would be way too much effort. As you were talking, I just had the idea that if you have these different requirements, what you could do is set up different scenarios. Mm-hmm. So for one scenario, you feed only CSV for your one customer, the second one for the second, and the third one for the third. And with those scenarios, you can then basically say, based on your traffic patterns, what the ratio should be between the different scenarios.
Mm-hmm. Ah, okay.
So that's probably the approach that I would take.
Yeah, cool. Yeah. Mm-hmm. Got it. Thank you.
And then in the reports, you have the scenarios already separated out in the report. And then you can also say, okay, what happens if customer 2 suddenly gets bigger and doesn't have 30% anymore, but suddenly that person's up to 50. So you can run those scenarios and see how your system behaves with different customer requirements.
Cool. Yeah, that helps. Thank you so much.
Mm-hmm.
Cool. Thank you both. All right. The next question we have is from Dennis or Denis. I don't know how you pronounce your name, but I'm going to read out your question. So you mentioned in the beginning that performance testing should be done from the very start to better see when a regression is introduced. Does Gatling support diffs or differences between reports to better compare a current run to previous ones?
No. Well, let me not be so deterministic. I would say not to my knowledge. And in fact, that's actually a problem that I have been thinking about as well. So I'll tell you a little secret. My next little project here with Gatling, when I get a little bit of air with my project right now, because Gatling writes these beautiful HTML reports, but they also write down into the report or into the report for each test run a JSON file that contains all the information that is displayed graphically in the UI. So what I have in my mind is that if we're using a continuous deployment kind of a pipeline like GoCD, for instance, that we're running our tests, and once the tests are done, the next step would upload this JSON file to a separate microservice, server, whatever, which accepts it, and then you can build a graph of performance statistics over time. So you basically write them into a database, and then you can export that and maybe use a spreadsheet, as a first iteration. And part of me is thinking that maybe there is a tool out there that already parses this. Otherwise, it'd be a fun little weekend project for the next 10 years for me to write a tool like that. But that's the approach that I would take, is to basically see a progression of the performance metrics over time based on these JSON files that get generated. Did that answer your question, or did I miss it?
Dennis, Denis, can we get a thumbs up, or you can even unmute yourself if you want further clarification or to say yes, it was great. We will assume, oh, yes, okay, in the chat, yes, it did, thank you, or thanks.
Perfect.
Nice. All right, it looks like for the moment, at least, the questions that have been asked, you've already answered, Torsten, so thank you so much. I don't think I missed any, but if you do have any more questions, now would be the time to share them. Of course. Yeah. And oh, okay, I'm seeing some claps, yay. Okay, and if you get a chance to look in the chat messages later, Torsten, or now, you're getting some thanks and thanks for the detailed presentation and all this great information. So getting some shout outs from the audience, which are well deserved. So very cool.
Yeah, I actually just opened the chat, and yeah, so thank you. I'm glad it was helpful to people. I'm glad you liked it and didn't feel like this was an hour and a half wasted. So thank you for attending. It was fun for me too.
Yay, cool. Thank you so much, Torsten. Thanks also to our audience. So glad that you joined tonight. Wishing everybody a great rest of your evening, and we look forward to seeing you next time.
All right. Bye, everybody.